Practice set 3.5. 1. In the figure, ray PQ touches the circle at point Q. PQ is equal to 12. PR is equal to 8. Find PS and RS. Here's the solution. In the figure, ray PQ touches the circle at point Q. That is, PQ is the tangent of the circle. Secant PRS intersects the circle in points R and S. By tangent-secant segments theorem, PQ square is equal to PR into PS. It is given that PQ is equal to 12 and PR is equal to 8. Substituting the given values, we get 12 square is equal to 8 into PS. Therefore, 144 is equal to 8 into PS. Therefore, PS is equal to 144 upon 8. Therefore, PS is equal to 18. Now, point R lies between points P and S. Therefore, PS is equal to PR plus RS, which means 18 is equal to 8 plus RS, and therefore RS is equal to 10. Answer: PS is equal to 18 and RS is equal to 10. In the figure shown here, chord MN and chord RS intersect at point D. 1. If RD is equal to 15, DS is equal to 4, MD is equal to 8, then find DN. Solution. Observe the figure. Here, chord MN and chord RS intersect each other inside the circle at point D. Therefore, by theorem of internal division of chords, RD into DS is equal to MD into DN. Substituting RD is equal to 15, DS is equal to 4, and MD is equal to 8, we get 15 into 4 is equal to 8 into DN. Therefore, DN is equal to 15 into 4 upon 8, which is equal to 15 upon 2, that is equal to 7.5. Therefore, DN is equal to 7.5. So the answer is DN is equal to 7.5. 2. If RS is equal to 18, MD is equal to 9, DN is equal to 8, find DS. Here, RS is given to be 18, MD is equal to 9, and DN is equal to 8. We have to find DS. RS is equal to RD plus DS since RDS. Let DS be equal to X. Therefore, 18 is equal to RD plus X. Therefore, RD is equal to 18 minus X. The chords RS and MN intersect each other internally at point D. Therefore, by internal division of chords theorem, RD into DS is equal to MD into DN. Substituting the given values, we get 18 minus X into X is equal to 9 into 8. Therefore, 18x minus x square is equal to 72. Therefore, x square minus 18x plus 72 is equal to 0. To find x, let us solve this quadratic equation by factorization. Can you factorize this and solve it? Okay. X square minus 18x plus 72 is equal to 0. Therefore, x square minus 12x minus 6x plus 72 is equal to 0. Therefore, x into x minus 12 minus 6 into x minus 12 is equal to 0. Therefore, x minus 12 into x minus 6 is equal to 0. Therefore, x minus 12 is equal to 0 or x minus 6 is equal to 0, which means x is equal to 12 or x is equal to 6. Therefore, ds is equal to 12 or ds is equal to 6. So the answer is ds is equal to 12 or ds is equal to 6. Three. In the figure, O is the center of the circle and B is a point of contact. Segment OE is perpendicular to segment AD. AB is equal to 12. AC is equal to 8. Find 1. AD, 2. DC, 3. DE. Here's the solution. In the figure, line AB is the tangent at point B, and line AD is the secant intersecting the circle at points C and D. Therefore, by tangent-secant segments theorem, AB square is equal to AD into AC. Substituting AB is equal to 12 and AC is equal to 8, we get 12 square is equal to AD into 8. Therefore, 144 is equal to 8 into AD. Therefore, AD is equal to 144 upon 8, which is equal to 18. So we obtained our first answer. AD is equal to 18. Now let us find DC. Points A, C and D are collinear points, and point C lies between points A and D. Therefore, AC plus CD is equal to AD. Substituting the values of AC and AD, we get 8 plus CD is equal to 18. Therefore, CD is equal to 18 minus 8, that is equal to 10. That is, DC is equal to 10. How will you find DE now? Which theorem or property will you use? Correct. Segment OE is a perpendicular drawn from the center O of the circle to the chord DC. We have learned the theorem. The perpendicular drawn from the center of the circle bisects the chord. Therefore, point E is the midpoint of chord DC. Therefore, DE is equal to EC is equal to 1 upon 2 into DC. Therefore, DE is equal to 1 upon 2 into 10, that is equal to 5. Therefore, DE is equal to 5. Answer: 1. AD is equal to 18. 2. DC is equal to 10. And 3. DE is equal to 5. Four. In the figure, if PQ is equal to 6, QR is equal to 10, PS is equal to 8, find TS. Solution. Look at the figure. Here, chords TS and RQ intersect each other at point P in the exterior of the circle. Therefore, by theorem of external division of chords, we get PT into PS is equal to PR into PQ. It is given that points P, Q, R are collinear points, and point Q lies between points P and R. Therefore, PQ plus QR is equal to PR. Therefore, 6 plus 10 is equal to PR. Therefore, PR is equal to 16. Similarly, points P, S, T are collinear points, and point S lies between points P and T. Therefore, PS plus ST is equal to PT. Let ST be equal to X. Then PS plus X is equal to PT. Therefore, PT is equal to 8 plus X. Substituting these values and the given values in PT into PS is equal to PR into PQ, we get 8 plus X into 8 is equal to 16 into 6. Therefore, 64 plus 8X is equal to 96. Therefore, 8X is equal to 96 minus 64. Therefore, 8X is equal to 32. Therefore, X is equal to 4. Therefore, ST is equal to 4. That is, TS is equal to 4. So the answer, TS is equal to 4. Five. In the figure shown here, segment EF is a diameter and segment DF is a tangent segment. The radius of the circle is R. Prove that DE into GE is equal to 4R square. The proof. Line DF is the tangent touching the circle at point F, and line DGE is the secant of the circle intersecting it at points G and E. Therefore, by tangent secant segments theorem, DF square is equal to DE into DG. Let this be statement 1. Now it is given that EF is the diameter and DF is the tangent. Therefore, by tangent theorem, angle DFE is equal to 90 degree. Therefore, triangle DEF is a right angle triangle. Therefore, by Pythagoras theorem, DE square is equal to DF square plus EF square. It is given that the radius of the circle is R and EF is the diameter. Therefore, EF is equal to 2 into R, that is equal to 2R. Therefore, DE square is equal to DF square plus 2R the whole square, which is equal to DF square plus 4R square. Therefore, DE square minus DF square is equal to 4R square. Therefore, from statement 1, DE square minus DE into DG is equal to 4R square. Therefore, DE into dE minus dG is equal to 4R square. But dE minus dG is equal to GE since G lies between D and E. Therefore, dE into GE is equal to 4R square.